section 5.2, okay, the definite integral, okay. So this is the definition of the definite integral, okay. So I'm going to read this part for us, okay. In the previous section, which is section 5.1, we've seen how to use Riemann sum to calculate the area under the curve, okay. So Riemann sum. What is a Riemann sum? Remember we used what? We did several practice questions about what? Oh, if we cut this region S by many strips, right? And then we use what? Those little, rectangles to approximate each of those small strips, okay? And then we add up the areas of those rectangles. That is called what? Riemann sum, okay? Now we denote the limit of the Riemann sum by the symbol, okay? So we get this conclusion, okay? Integral of f of x dx, where x varies from a to b, equals limit n, where n goes to infinity, of sigma I from 1 to n, f of I star delta x. Okay, so it says, okay, definite integral is defined by what? The limit of the Riemann sum, okay, limit of the Riemann sum, okay, limit of the Riemann sum. So what is a Riemann sum? Later when we talk about Riemann sum, you have to know what is Riemann sum. Riemann sum we use R, Riemann, right, R, initial R, okay, n, which equals what? Sigma when I from 1 to n, f of xi star times by delta of x, okay? So Riemann sum is a sum of those what? Rectangles, okay? For each of the rectangle, okay, the area for each rectangle equals what? Length, which is what, or height of the rectangle is f of I star. What is the width of the rectangle? Delta x, okay, delta x. I think you should know that, okay. So each of the product gives us the area for a rectangle, and then eventually we add up all of those areas of the rectangle, which give us the I from 1 to n, okay. So this means what? This means when I equals 1, we have f of x1 star times delta x, okay. And plus what? When I equals 2, we have f of x2 star times delta x, plus until what? When I equals n, so we have plus f of xn star times delta of x, okay? So the reason why we're using a star means what? That's a sample point, okay? So xi star is a sample point in that interval, okay? In that interval, okay? In each sub-interval. Right? So this is called Riemann sum. Okay. Later when it comes a question to let us, can you please come to Riemann sum? Blah blah blah. You have to know what is Riemann sum. Okay. Your Riemann sum is this. Okay. And then the limit of the Riemann sum when n goes to infinity, this whole thing. Okay. We use this notation, which is called what? Definite integral notation to denote it, okay? So this is, okay, where delta x equals b minus n, a over n. Delta x is what? The length for each of the sub-interval, right? And xi star is a sample point, okay? So this thing is called what? The definite integral of f of x from a to b, okay? And here, the numbers a and b are called what? A is called the lower limit of the integration, and B is called the upper limit of the integration, respectively. Okay, and we call f of x is what? Integrand. Okay, integrand. Okay, so now we know. Oh, how do we define a definite integral? Okay, so we know. Oh, integral of f of x dx. Okay, from a to b means. Oh, we're gonna. Okay, what is the geometric meaning for this definite integral? Area, okay, of the region S, which is bounded by y equals f of x and y equals 0, okay, and when x equals what? A, and x equals what? B, okay. So the area of this region S, okay, the area of the region S equals the limit, okay, of this Riemann sum. And also we can use what? A definite integral to describe this limit. Use this definite integral to describe what? The area. Okay? So later when they ask you, oh, how do you understand this definite integral geometrically? Think about the area problem. Okay? Oh, this definite integral means what? The area, okay, which is under what? Function, under the curve y equals f of x, and between, above y equals 0, and bounded between these two vertical lines, x equals a, x equals b. Okay? Alright, so this is some explanation. It's the same thing, okay? Yeah, definition is this much, okay? So I hope you understand the definition. And then for this paragraph and this theorem, okay, I want you to read all by yourself. It's the same thing, okay? The definite integral equals this limit where dart of x equals mu minus a over n, and xi equals what? A plus I times by dart of x. Okay, yeah. So each of those, this xi are the endpoints. Okay, the endpoints of those subintervals. Okay, so each xi equals A plus I times by dart of x. Okay. Alright, so you can read this theorem and this paragraph by yourself. Alright, now let's look at practice question directly. Okay, so this example, express the limit as a definite integral on a given interval. How to express this limit as a definite integral? We know the limit of the sigma of f of I star dart of x can be written by the integral, okay, if we know the two limits, right, lower limits and the upper limits, okay, and we need to figure out what is f of x from the given, okay, expression, and then dart of x we can rewrite it as what? D of x means this is what? This is called a this is d of x. This is a derivative of x, okay, but we'll integrate about it, okay. So dart x will rewrite it as d of x, f of x I star, we can tell what is f of x, and then we know a and b, we can write it as a definite integral. Now guys, from this problem, can you tell f of x? Limit sigma, what is f of x from the given expression? Can you tell? This will be our f of x, right? F of x equals what? E to the x over 1 plus x, right? So how to use definite integral to rewrite this limit? Definite integral, we must write a integral sign. What are the a and b value? Is it given? A and b are the what? Endpoints from the given interval, right? Are they given? What is a? 0. What is b? 1. Okay. And what is f of x? Here given. E to the x over 1 plus x, right? And then we do not write delta x, we write dx. Okay. Can you mimic this question A and try question B? From this limit, can you tell the f of x? And are the a and b values given? Yes. So what is f of x? This thing, right? Everything except the delta x. So I will write this definite integral directly. Okay. A equals 2, b equals 5. F of x will be x times by square root of what? 1 plus x to the what? Cube, and then what? dx. 수고하셨고요. Alright, let's move on to the next page. Evaluate Riemann sum for f of x equals x to the cube minus 6x. Taking the sample points to be the right endpoints and a equals 0, b equals 3, and n equals 6. Okay, and then question B, we don't do it, okay, because there are some, hard part. I will not test you about that either, okay? So just use a Riemann sum to evaluate, okay? Yeah, just evaluate the Riemann sum for this function. When a equals 6 means what? How many rectangles should we create? 6, right? And then when a equals 0, b equals what? 3, okay? So that means when, x, when x is between 0 to 3, okay, we're going to create 6 rectangles, and then we're going to create 6 rectangles by using the right endpoints as the sample points, and then find the areas for those 6 rectangles, add them up. That will give us the Riemann sum, R of 6, right? Guys? Well, the thing is, where is this function f of x? We have to know how to draw a picture for f of x equals x cubed minus 6 of x, right? Remember this, right? So it's like we have to review for chapter 4, right? How can we draw a picture for f of x equals x to the cube minus 6x? Do you still remember those 8 steps from chapter 4? In order to draw a picture for this function, first we should find what? Domain, right? Domain. Do you have any restrictions for this function? No? So domain is all real numbers, right? No restriction. What is the second criteria? What? Intercept, right? Intercept. So I'm going to write on the side, okay, on the side. So to find the x-intercept, we should let y equals 0. To find the y-intercept, we let x equals 0. X equals 0, y equals what? 0, 0. Okay? So y-intercept. How about x-intercept? Let y equals 0, solve for x, right? Let y equals 0, solve for x. So how? X to the cube minus 6x. Let y equals x to the cube minus 6x equals 0. Solve for x. Let's see. Factor out x. X squared minus 6 equals 0. So we can have x times by x plus square root of 6, x minus square root of 6 equals 0. So 3 factors, okay, equals 0. Each factor must be equal 0. So we should have a 0. What is the other value for x? Negative square root of 6, right? And x minus square root of 6 equals 0 give us positive square root of 6, right? So these 3 are our what? X-intercept, right? X-intercept. So let's locate this intercept. Means our graph must pass through these points, okay? I would say 0, 0, negative square root of 6, 0. What is negative square root of 6 in decimal number? Negative 2 point something, right?
0.45 just about.
Yeah, negative 2.45, okay. So I would say, oh, it is here. Negative 1, negative 2, negative 3. And we don't have to worry about it. Why? Because eventually we'll only worry about our graph when x varies between what? 0 to 3. So we don't have to worry about when x is less than 0. Okay? We'll only worry about when x is between 0 to 3 actually. You agree with that? So 1, 2, and 3. Okay, so the other x-intercept is what? 2.45, right? Yeah, so I would say here, okay, square root of 6. Okay, so that means our graph between 0 and 3 will, we only need to care about when x is between 0 to 3, okay? There are 2 intercept, means graph must pass through or touch these 2 points, right? Alright, so I would say in order to graph this picture, easily between 0 and 3, we can also use another method called what? Key points, right? Key points. So when x equals 0, this is x, this is y, x to the cube minus 6x. When x equals 0, what is y? 0. When x equals 1, what is y? What?
-5.
-5, okay. Oh, 1 down to -5. 1, -5 here, okay. And when x equals 2, what is the y value then? 2 to the cube minus 6 times by 2 give us what? 8 minus 12, -4, right? So this is -4. I may have to draw another picture somewhere, okay? And then when x equals 3, 3 to the cube minus 6 times by 3, 27 minus what? 18 give us what? 9. Oh, so 9 is a number way up somewhere, okay, somewhere. Guys, do you see a briefly picture? The picture does not have to be very accurate. Does not have to be. This point may not be even the lowest point, okay? Because we don't know, when the graph change, okay, from decreasing to increasing. We have to find the derivative, okay? But I would say just graph it, briefly, right? Briefly, because eventually we have to compute the specific what? S value, so we don't have to worry about it. So I would say briefly, the graph between 0 and 3 have a tendency looks like this, right? Because these points are our key points, okay? That means our graph must pass through this key point, okay? So even if, this point may not be the lowest point, maybe somewhere else to the left or to the right, but briefly, okay, the graph looks like this, okay? So question is, okay, where is a region S? Region S is bounded, this region S is bounded between what? This curve, y equals f of x, and what? Between y equals f of x and y equals what? 0. Where is y equals 0? This, right? So, what is our region S? The shade area is our region S, okay? Because see, between 0 when x equals 0 to x equals square root of 6, okay? The curve is below the x-axis, okay? So the area, okay, the region between y equals 0 and the curve is here. When x is between, x is from square root of 6 to x equals 3, the graph is above the x-axis, right? So the region between the curve and y equals 0 is this, right? So the shaded area is our region S, right, you guys? So we want to find the Riemann sum for this function, okay? That means what? We want to find a Riemann sum, okay, create those, rectangles in order to approximate what? The area of this shaded region, right? Okay, so Riemann sum, okay, from 0 to 3, create 6 rectangles. Let me, ask you. From 0 to 3, create 6 rectangles. What is a delta x? Delta x is what? The length for each of the subinterval, right? Delta x should equals what? b minus a over n, right? What is b? 3, 0 is 1, n is 6. So 3 over 6 is what? 0.5. That means for each of the what? For each of the rectangle, okay, the width of the rectangle has to be what? 0.5, right? So from 0 to 3, cut into 6 subintervals. Each subinterval will have what? 0.5 as the width, okay? So 0.5, 1.5, there's a 2.5 somewhere, okay? So let me use a different color, okay? What endpoint, what sample point should we use? Right endpoints, right? So that means from this subinterval from 0 to 0.5, if we're going to draw a rectangle, how? Use a right endpoint, 0.5. Draw a vertical line until it touches the curve. And and then draw a horizontal line until it touches the y-axis. So this is what? Our first rectangle, right? First rectangle. So here, Riemann sum R of 6 equals what? What is the area for this first rectangle? We know the width is what? Delta x, right? What is the length of this rectangle? It has to be what? F of what? 0.5, right? Do you get that, right? So this is f of 0.5, okay? So f of 0.5. The value of f of 0.5 may be negative, okay? It may be negative, okay? So that's okay, okay? So that means the area for this rectangle is negative, okay? Yeah. All right. Then second rectangle, use a second line segment. Right endpoint is when x equals 1. Oh. Okay. So we're going to use what? Computed area for this rectangle. Okay. The width is still delta x. What is the length? F of what? 1, right? F of 1. Plus what? F of what? 0.5, right? 1.5, okay. This red endpoint is 2. This this is what? 2.5 is somewhere. This is 2.45, so we say here. Okay, and eventually 3. Okay, so f of 1.5 times delta of x plus f of what? 2 times delta of x plus f of 2.5 times delta of x plus f of 3 times by delta of x using right endpoints. You guys agree with that? Okay, now what do we do? Because every product have a delta of x, I pull the delta x out. What is the delta of x? 0.5, right? So 0.5, I write it outside. This is delta x, okay, it's 0.5. And then we only need to compute what? This f values, right? F of 0.5 means what? Well, x equals 0.5. So 0.5 to the cube minus 6 times by 0.5. This is one value for the function. Then plus what? F of 1 is when x equals 1, right? 1 to the cube minus 6 times 1, right? And plus x equals 1.5. 1.5 cube minus 6 times by 1.5. X equals 2. 2 to the cube minus 6 times 2. Plus 2.5 to the cube minus 6 times by 2.5. Plus what? 3 to the cube minus 6 times by 3. Whew. So we have to compute these values one by one. I will give you what's up?
I do have a question, which is that some of them are going to be negative, some of them are going to be positive.
Yes.
But
because this shaded area, it is because it is below the x-axis. So eventually, these rectangles, okay, the area for these rectangles, see, they're below the x-axis, will have negative areas, okay? Because even the shaded area, the original region, will have negative values. So this part of the area is what? Negative. This part, the area for this upper x-axis, it will be positive. So they may offset some. However, eventually the answer is negative because you have more regions on the below the x-axis.
I just didn't know if you were allowed to have like a negative.
We do. Okay, yeah, we do. Okay, because not every function, given function f of x, they're always above the x-axis. See this one, part of the graph is what? Below, part of it is above. So it depends on which is with more, right? See, the negative part with more. See, this is negative, this is positive. So eventually we'll have a negative results. Okay. Yeah, these questions are not hard, but it's kind of tedious, right? What do you get, Brittany?
ผมว่าหนักเนี่ย
Yeah, we can check his answer here. See, this is an example from the textbook, right? R of 6 equals the sum of these products. So you see, the four rectangles all have negative area, right? And then the last two has positive area, right? So eventually answer is what? Negative 3, hold on, negative 3.9375. Okay, see here, it's in the book, right? This is a graph, right? Okay, so this is this example, right?